Hey guys, down here. All right, so today we're going to be talking about identifying protons, neutrons, and electrons in a periodic table, as well as Bohr models. So, starting off at the very top up there with the hydrogen atom symbol from the periodic table, the one on top is going to be the atomic number for that element, and right underneath you have the H, which is the atomic symbol, and below that you have the atomic mass. Now, every element on the periodic table right above me, right there, has an atomic number, an atomic symbol, and an atomic mass, and they tell you very different things. So, the atomic number of an element can tell you quite a few things. So, when you look at an atomic number, it can tell you the number of protons, and it'll also tell you the number of electrons, which is very, very important whenever we're drawing Bohr models. Again, atomic number tells you the number of protons, the number of electrons. And there's a very easy way to remember this. And we use an acronym that goes, or it's called APE, A-P-E. And A equals P equals E. And what that means is that the atomic number equals the number of protons. It equals the number of protons, and it also equals the number of electrons. So if you ever want to know how many protons an element has, look at the atomic number. If you want to know how many electrons it has, look at the atomic number. The atomic number will tell you the number of protons and the number of electrons. Now, we know the number of protons and the number of electrons. What about the neutrons? Again, if all we have is the atomic or the symbol from the periodic table, we need to figure that out. So we use MAN, and MAN stands for mass minus atomic number equals the number of neutrons. So if we subtract the mass, the atomic mass, from the atomic number, that will give you the number of neutrons. Now, one thing real quick that I want to go through is the atomic mass. Sometimes you'll see decimals rounded down or rounded up. We like whole numbers. On that one right above with hydrogen was a 1.008. Let's round that down to 1. All right, so remember that the number of electrons an element has can be identified by looking at the atomic number. And I know that I'm repeating this over and over again, but it's very important that you remember that when we are looking at the periodic table and we're going to draw a Bohr model, you want to look at the atomic number to figure out the number of electrons. For example, we have hydrogen at the very top. Hydrogen has an atomic number of 1, which tells me that there is 1 electron. Beryllium, Be. Beryllium has an atomic number of 4, and that tells me that there are 4 electrons. And then we have argon. And argon is Ar, which is number 18. That tells me that atomic number is 18. There are 18 protons, 18 electrons. Now, Bohr models are these diagrams that we use to be able to visualize what an atom looks like and be able to draw it and represent what that atom would look like. And it's very important that we are able to do this because we need to see the characteristics of the atoms sometimes. So we have to be able to, again, draw them out. But to be able to do this, you need to know the number of protons, the number of electrons, and the number of neutrons. Without those three, you can't draw the Bohr model. Now, when you're drawing the Bohr model has a nucleus, which is the center. And again, the best practice for this is to draw it a different color. Don't ever confuse the nucleus with the rest of the shells, because that's just where the protons and the neutrons go. You don't add any electrons to that circle because that's the nucleus. The electrons go on the outer circles. So again, you have your nucleus containing the protons and the neutrons, and then you have your electrons in these concentric circles, or circles that one after the other getting bigger and bigger. So again, this one that I'm drawing right here, this is going to be the nucleus. This one does not count as one of the electron energy shells. Now, I should have probably drawn it a different color. It's a little late for that. Can't really do anything about that. I can't really change it now. But nonetheless, the first circle on there is going to be the nucleus. And I do notify you in a bit. I do draw an arrow towards it And you can also see that there's a proton in there, or there's protons and the neutrons as well. But I do do a little arrow that shows that that is the nucleus. Again, no electrons go in that circle. That's not an electron energy shell. That's just to represent the nucleus, where again you find your protons and your neutrons. Now, the other two circles, those are energy shells. And this element that you are representing in this Bohr model has two energy shells. And some of them have 3, some of them have 4, some of them have 6, up to 7. Or some of them only have 1. And we'll talk about that in a little bit. So only a certain amount of electrons can be placed in each circle, or fit per circle. You can't just throw all the electrons on one of the energy shells and then call it a day. That's not how that works. You do have to put a certain amount of electrons per circle depending on the number of electrons that you have. And again, you can figure out the number of electrons that that atom has by looking at the atomic number of the element that you're looking at. So if you ever need to figure out how many electrons fit per shell, you can use the formula 2 parentheses n squared. And the n is replaced with the number of that energy shell. So let's say that you want to look up the first shell, the one right after the nucleus. So the first shell, you do 2 parentheses, and instead of n, you put 1 for the first shell squared. So 1 squared is going to be 1. 1 times 2 is 2. Again, ugly number. Need to draw it a little bit more clear. But again, 2 times 1 is 2. So the first energy shell only fits 2 electrons. Now the second energy shell, again, replace that n with the 2. 2 squared is 4. 4 times 2 is 8. So the second energy shell holds only 8 electrons. And the third one, again, do the same thing. For the n, replace it with a 3. 3 squared is going to be 9. And that's going to give you 2 times 9 is 18. So the third energy shell fits 18. And the fourth one fits a certain amount. And the fifth one fits a certain amount. And again, you can figure that out. But we won't be getting anywhere near the 5th or 6th or 7th energy shell because you're just going to be drawing too many circles. So to find out the number of shells that you are going to be putting, or circles that you're going to be putting in a Bohr model, there's something that you have to do. And you have to look at the periodic table to be able to do this. So again, this is why it's very important that you have a periodic table. And again, either download one from the internet. Best one to use is the one that I have up there, which is the 8th grade star periodic table. There's a ton of periodic tables online, but again, that one is probably the best one because it's the one that you're going to see on the STAR test, and it's also numbered on the side, and that plays a key role into what you're about to learn right now. So I'm drawing an arrow going all the way back up, and hopefully I don't block anything with my face down here when I do scroll back up. Awesome. I do not, at least not yet. So on the left-hand side, right there, you see it numbered 1 through 7. Those are your periods. That is what they're called. They are periods. So you have period 1 where hydrogen is, period 2 where lithium is, 3 where sodium, 4 potassium, 5 rubidium, 6 cesium, 7 francium. And these are used. They're used horizontally, not vertically. So you look at them horizontal. So let's say period 1. That means at period 1, hydrogen and helium only have 1 energy shell, which makes sense because hydrogen only has 1 electron. You don't need more than 1 energy shell when you can only fit 2 in the first energy shell. Second period, number 2, has 2 energy shells. Third period has 3 energy shells. 4 has 4 energy shells. 5 has 5 energy shells. Period 6 has 6. And period 7 has 7, as you can tell by the circles that I'm drawing around the numbers. Now, you don't need to draw circles. I usually draw little lines. So for 1, I'll draw 1 line underneath. For 2, I'll draw 2 lines, just so I know. It's a good way to memorize. And again, they run horizontally. So everything in that horizontal line is going to have that number of shells. So again, hydrogen and helium have 1 energy shell. Lithium, beryllium, boron, carbon, nitrogen, oxygen, phosphorus, and neon have 2 energy shells. Sodium, magnesium, aluminum, silicone, so on and so forth. In that one, have 3. And again, it just runs horizontally. So that's an easy way to know how many shells you're going to have in your Bohr model. And again, I try to cut it in a little bit. I don't know what was going on with this picture. They didn't let me highlight, but you can see that the first one's blue. And then so I think so is the second one. The third one's going to be red because, again, they're red horizontally. They're read as rows, not as columns or up and down. It's going to be horizontal. So again, period 1 is horizontal, hydrogen, helium. Period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, phosphorus, neon. 3 is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. 4 is potassium, calcium, selenium, titanium, so on and so forth. Again, there's a whole lot of them.